When events happen to us, when they happen to people we know, when they happen to the people who know the people we know, it leads to something called a ripple effect. This video is the study of those ripple effects and explains how you can calculate the size of those ripples as they reach out from you or come upon you. My name is James Cook. I'm an associate professor of sociology at the University of Maine at Augusta, and I'm recording this video for the UMA social science program. But I'm working with insights that were generated after an event half a generation ago. H. Russell Bernard, Peter Kilworth, Eugene Johnson, Gene Shelley, and Christopher McCarty got together in the weeks after the attacks of September 11, 2001, when a reporter asked them, "How many people do you know who experienced this event? And how many people in general know someone who experienced the attacks of 9/11?" So the authors returned from having spoken with that uh, reporter and realized that in the wake of September 11, there were actually two kinds of conversations that were happening all wrapped up in one. After the attacks of September 11, if you were alive during those times, you'll remember that people said two things. They asked the question, was anyone that you know hurt? And then the person who was asked if the answer was yes would say, unfortunately, yes. Often, though, they would say something else. They would say, no, but my aunt knows someone who was killed, or my brother's cousin was killed, or my wife's coworker was killed. The first question, do you know anyone who experienced the event, is happening at what's called a network distance of 1. A network distance of 1 means that you're talking about something that may have happened to people that you knew. When they responded and they said, no, but my wife's coworker did, what they're saying is, I didn't know anybody, but I know someone who knew someone. That's two relationships, right? A remove of 2, also known as a network distance of 2. Both of those experiences have a feeling of reality to them, a feeling of importance to them. And this is not coincidental. There have been other studies that have been done of academics and other sorts of reputation that indicate that up to a network distance of 2, we feel as though something is impacting our lives. If someone we know is hurt, or if someone we know had someone who was hurt, we feel as though it touched us. That's how far knowledge tends to go. And so to know the size of these ripple effects is to know how many people are feeling them. How many people are feeling activated by an event? To calculate this, H. Russell Bernard and colleagues have a very simple kind of uh, equation. They don't express it very simply, but it's amazingly simple, and it can be used to describe any kind of event. For instance, this was generated in response to the attacks of September 11, 2001, but it could be used in the current day. And by current day, I'm recording this in 2020. And so we could ask how many people know someone who died in the United States coronavirus outbreak, or how many people know someone who knew someone who died in the United States coronavirus outbreak. We can also describe events that are ongoing. And this is an interesting point that we'll return to. You might consider the question, how many people know someone who was sexually abused as a child? Or how many people know someone who knows someone that was sexually abused as a child? That's an event that occurs every year, and it accumulates into this event of people who had experienced this in the past. So in order to estimate that ripple effect of a disaster, it's astonishingly simple, with just a few wrinkles. First of all, you need to know the size of the event. Bernard et al. And his others, who helped co-author this, called it the size of the event. It's E. It's the number of people who were affected. Then you need to know how many people someone knows. And Bernard et al. Think about knowing in terms of acquaintanceship. When we ask this question, did you know anyone who was hurt? We don't mean were you married to someone who was hurt. We don't even mean were your best friends hurt. We mean, are you aware of someone in your life that has some permanence to you that was hurt? And so that kind of permanence means you know their face or you know their name, and you have encountered them sometime in the recent past. It turns out that Bernard and his co-authors and their co-authors, the Network Distance 2, had been doing a lot of research on exactly what the average size of that is. And it turns out they found the average size of a personal social network of acquaintances in terms of knowing someone by name or face, and you know how to get in touch with them if you need to, is about 290 people. So there's a bit of a problem that they identify, which is that if there are E people in the event, right, and then each of those E people knows 290 people, some of the people who are in the event will know some of the same people. So say this person knows 290 and this person knows 290. Well, the fact that they're in the same event means that they're probably themselves connected to some of the same people. So they also, it turns out, have accounted for this with something they call lambda. And we can think about why did they use the letter lambda, and there are cultural reasons, but it boils down to because they felt like it. So you just have to stick with that. But they found that on average, that lead-in factor, their largest estimate of it was 1.6. So they said, we're going to use that figure, 1.6. And that factor means you need to divide by that in order to reduce your estimate of the size of the set of people C times E who are knowing someone who is in E the event. Because some of the people C, if you do C times E, right, you just count 290 people times each of the people in E, well, you'd count some people twice. So divide by 1.6. And that's what is represented in what they call N1, a network distance of 1, the total number of people who know people who were in the event E. And to do that, all you need to do is multiply the size of the event, the number of people there, multiply it by the 290 for each person, and then divide by lambda 1.6 in order to account for the fact that some of them know the same people. So you don't want to overcount. Now the trick is that then you can take that N1, the total number of people who know that people, and you can call it itself an event. And then you can count outward from there. And you can say, what's the total number of people who know people in E? Right? The number of people who know people in E. And that is N2. And you take N1, the size of the total number of people who know people in E, and you multiply it again by 290 and again divide by 1.6 because N1 is the new event. And then you know the number of people who know someone in E, that's N1, and the number of people who know someone who know people in E, and that's N2. And that's as simple as that. But let's take this idea and let's now calculate this for some actual events. So to do that, I'm going to move over to a spreadsheet. And in this spreadsheet, I've created a number of columns. I'm going to make this a little bit larger and a little bit larger again. And we're going to start with the work that H. Russell Bernard and colleagues described, the deaths on September 11, 2001. Now, at the time they wrote it, they thought it was larger than it turned out to be. The early estimates were 6,000. It turned out the number of people who died in the United States on September 11, 2001, and all the attacks was 2,996. So we're going to correct their work a little bit. It was published very quickly in those early months. 2,996 is E, the event size. The average network size of acquaintances is 290. The people we know in the sense of being familiar with, acquainted with on average. And our lead-in factor is 1.6. So what we would need to do is indicate an equation in Microsoft Excel. It would be the same in Google Sheets. And we're going to multiply E, the event size, which is cell B3. See, it's highlighted here. And we're going to multiply it by C3, which is the network size. And then we're not going to forget to divide by D3, that lead-in factor. And that's going to indicate for us that the number of people who know people who were killed on September 11, 2001, not just involved, but killed, because that's our event size E, the number of people who died, is actually 500,000 people. That's a lot of people who know someone who died on September 11, 2001. What about people who don't just, when you ask them, did you know someone who died, didn't just say yes, but perhaps might have said no, but my contact, a person I'm acquainted with, knows someone who died on September 11, 2001. Well, to do that, we would take N1 as the new E, the new event. And so we would, again, type in for our E, which is now E3, right? That 543,025 people, we'd multiply it by C3, the average network size, and then we would divide by D3, our lead-in factor, because some people who know those people are also counted when they know other people. And that turns out to be a large number of people. 98,423,281 people. In 2001, could have said, in answer to that question, did you know someone who died on September 11, 2001? They could have said, no, but someone I know had someone they know die on them. That's a huge share of the population that experienced that effect. How huge? Well, we can judge exactly how huge by taking one more step, which is to take the United States population at the time, 285, not thousand, but million, and to recognize that we can think about this as a share, a proportion, or if you multiply it by 100, a percent. And that would be, if we take equals F3, the number of people who know people who know someone who died, and then we divide that by G3. And that gives us a whopping, when we think of it as percentage, right? That's a whopping 34.5% of the American populace. Excuse me, that is actually the share of N2, right? If we take F3 and we divide that by G3. And we'll put an equal sign in front. in front. That's 34.5%. More than a third of Americans could answer that. So even if you went out average and randomly and you talked to people in the United States, one of the three conversations you had, you would say, did you know someone who died? And 1 out of 3 times, someone would say no, but someone I know knows someone who did. That's a lot of the time. Think about that for a moment and compare that to the actual number of people who know someone who died directly, which would be taking this E3, the 500,000 people, and dividing that by the 285 million people. And that is not 19%, but 0.19%. 1/5 of 1% of the American population. So only one time in 500 would you ask someone a question and they would say, yes, I knew someone who died. That was a very rare event to know someone who died on September 11th, but an amazingly, overwhelmingly common event to know someone who knew someone who died, which we still take as feeling socially real, as socially close to us, even though the experience was not adjacent to us, which is what's going on with the 500,000 people. It's adjacent to us. It could have almost been someone we feel that we knew, because gosh, 1 out of 3 times we asked that question, somebody we talked to knows someone who died. In part, that's because we know so many people, and also because it was a question everybody asked of everybody. And we'll return to this later on when we think about other events. When everybody's talking about it and everybody's asking that question, the feeling of an event gets close. And that explains the feeling after the attacks of September 11, 2001, in which we felt like the terrorists were everywhere, even when they weren't. We felt like they had touched all our lives, almost directly, it felt like, even though, directly speaking, they had not. As of the date of this recording, March 31st, 2020, the number of coronavirus deaths is larger than the number of people who died on the attacks of September 11, 2001. It is 3,867 by current estimates. And that's a lot of people, to be sure. That's 3,867 tragedies. If you were to ask, do you know someone who has died of coronavirus? Well, this is a conversation you might be having a lot. You might be conversing with a lot of your acquaintances. You wouldn't have had Facebook on September 11, 2001. Facebook did not exist. But you could have asked that question in 2020. And over social media, we talk with our acquaintances. We find out by asking that sort of question. 290. A lead-in factor of 1.6. And here we can engage in the same calculation, but we get a higher number. 0.7 people, 700,894. If those averages bear out, can be expected to know someone already who has died of coronavirus in the United States as of March 31st, 2020. And that number is only going to get higher. What about the number of people who know people who have died of coronavirus? As of the recording of this video, this ongoing disaster gives us a number of 127,036,992. So that if you ask the question, do you know someone who has died of coronavirus? The answer on Facebook or another social media platform could be no, but I know someone who knows someone who has died. My sister's cousin has died. My preschool teacher's husband has died, right? Those kinds of phrases, which is indicating a remove of two. You can expect that to happen a lot. How much is a lot? Well, the United States population has grown a lot since September 11, 2001. It is now estimated to be about 329 million. So we can estimate the share. While only 0.21% of the American population knows someone currently who has died of coronavirus, 38, nearly 39% of people know someone who's died of coronavirus. That's going to happen a lot of the time if we have those discussions. So when we have smaller events that could be just as striking, like lightning strikes. If we were to go to weather.gov, the site of the National Oceanic and Atmospheric Administration, they would tell us that in the United States, 20 people died of lightning. Now, that's a much smaller event. Same network size, same lead-in. Excuse me. We get a much smaller number. Only 3,625 people in the entire country would be acquainted with someone who died of a lightning strike. Less than 1 million people would know people who knew people. And as a share of the population just about now, that's vanishingly small. Only 1 in 500 times, 0.20%, would we get the answer, yes, I know someone who knows someone who's died of a lightning strike. So that is not going to happen too often. We could consider even larger events. For instance, those who attended the Super Bowl. In 2019, Super Bowl 2019, that was 70,081. I looked it up. And we could talk about that event. And the number of people who would know someone who'd gone to the Super Bowl is 12 million, because that is a factor larger in terms of the event size, plus kind of a doubling of the coronavirus deaths, right? And the number of people who know people, there is, wow, that's 2.3 trillion people, which is, 2.3 billion people, which is more people than are in the United States. So when we compare that to the population, 329 million, well, we just have to say everybody knows someone who knows someone that went to the Super Bowl. And because it maxes out, you can't get any bigger than 100%. And a full 3.8% of the population knows somebody who attended Super Bowl 2019, which is a pretty striking figure. And yet, does it have the same striking reality to you as coronavirus deaths? Probably not. One reason is because it's not current. The Super Bowl is over. But another reason for that is that we think about the assumption in the Bernard et al. Model, and it is that we are going to find that information out about that 290 people, right? In other words, the assumption is, do you know someone who died of coronavirus deaths? Of coronavirus. If that happens, you're probably going to find out. And you're probably going to remember, for anyone that you're acquainted with, it will strike you. And if anyone asks you about that, you'll have something to say to someone else. So pretty close to all 290 people are going to talk about it. But if you say, did you go to the Super Bowl? And someone says, yeah, you might go, oh, that's interesting. And then you might forget about it. And also, not everybody talks about sports. There's things like the Super Bowl. Not everyone asks people randomly, did you go to the Super Bowl this last year? How about you? Did you go to the Super Bowl last year? Can you imagine somebody asking that of everybody? No. And yet, that is the kind of thing we do about coronavirus deaths, about a major disaster like that or September 11. So, how could we factor that in? We need a new factor, a new discount. And that is to think about the proportion between 0 and 1. You multiply it by 1, it's 100. 0 times 100 is 0. It turns into the percent if you multiply it by 100. The percent who talk about it, right? The percentage of those acquaintances to whom you talk about it. And, we could say that percentage, if it happened, the percentage that of your network size who are going to talk about it is 1. Or if it happened to people you know directly, the percentage of people you'll know about is 100%. The proportion is the percent divided by 100. Lightning deaths, maybe, that's pretty wild. Wow, did you know Sam was struck by lightning? Wow, holy cow. Maybe everyone talks about that. But about attending the Super Bowl? Maybe not. Maybe just 10% would talk about that. So then if you think about the knowing of it, the knowing of N1 would be if we're thinking about the share, it would be H6 times J6, which is the percent that are talking about it. And all of a sudden, that means that if we think about that then as a percentage, that would be just 3.386%. Because just a tenth of the people are going to talk about it. Whereas here, the percentages are going to be unchanged from over in that column, right? They're going to be unchanged because everybody's talking about it. Now, what about a really big event? Something that everyone talks, not that everyone talks about, but that has happened to many, many, many people, a really big event size. The number sexually abused as children. So, an article in the Journal of Adolescent Health in the last few years took estimates centering around the year 2008 of a representative sample of the United States and determined in interviews how many of them had been sexually abused as children. And the answer was more than 26%. Or if we're thinking about in 2008, when the population was 304 million people, then the event size would have been 80,864,000 people. There are 80,864,000 Americans who we can estimate were sexually abused as children. That's a lot. It's a huge percentage. The trick is, let's think about that 290. We can even talk about a 1.6, right? If everybody talked about that experience that they had, well, then pretty much everyone on the planet would know somebody. So we're talking about 14 billion people, which is more people than on the planet. Everybody, everybody would be acquainted with someone who was sexually abused as a child. And yet, only a third of people who have been sexually abused as a child, it's been estimated, have ever told anyone. Not just a third who've told everyone in their acquaintanceship network. Only a third have told anyone. So if the average network size is 29, well, that comes down to maybe 1.4 billion, but it's lower than that. Only one third have told one person. So it's really, in this case, 0.333. And that means still that the number of people who, now I'm going to put this in quotes, know that they know of people who have been sexually abused is actually lower than the number of people who are sexually abused. And then the number of people who would be able to say, no, I don't know anyone who's sexually abused, but um, my cousin knows someone who's sexually abused, right? If C is really 0.333, that transmissibility so low, one third have talked to one person, then it means that fewer people know people at a network distance of 2. So that we have, for a percentage of people who feel they know someone who was sexually abused, is just 6%. And for, let me make sure I got that right. Yeah, 5.53, rounded up is 6. And the percent who knows someone who knows someone, when I say know, meaning that there's a reported knowing, is lower, 1.15%. And that's because of the difference in who actually talks about it. A wrinkle that's worth thinking about when we think about events. There are events that are actually larger than the coronavirus deaths, and it's hard to say that at this moment. But some of those events are things that we don't talk about, and that leads to our social difference in the social understanding of the ripple effects of those disasters. With that in mind, may you be as well as possible during this disaster. And when the next one comes along, you know what to do. As a matter of fact, you can use this template, recreate it, and the next time an event comes along, you can estimate the ripple effect of that disaster, and how it affects people at a distance of 1 and a distance of 2. Hope this has been helpful. This has been James Cook with the University of Maine at Augusta. Thank you.